All right, and guess what time it is? It's the best time of your day. That's right. It is time for some math, man. So, today's lesson really is mostly a review of some of the concepts we've already talked about this year. But we are going to learn how, not learn how, review how to graph our quadratics in vertex form, something we've done several times this year. And then what our goal is for the next lesson is to talk about how to graph quadratics in standard form by making some connections to what we already do and already know how to do. All right, so let's take a look at our lesson here. And just I'm going to write this off here right to the top of the notes here, just in case, all right, you don't remember. But when we talked about this earlier this year, we talked about y equals a and then x minus h quantity squared and then plus k. And what we talked about was that HK is the most important point on that quadratic, and that is the vertex, and that's why we call this vertex form. All right, and there we go. All right, so HK was our vertex. And then we talked about A, all right, was the rate of change, all right, that we use to generate the additional points on our graph. So just real quick, if we come to example 1 here, all right, no warm up today, just jumping right in. I know that disappoints you not to have those 3 warm up problems at the top, but I thought we'd vary it a little bit, give you a little mix up today. All right, so looking at our equation here, we know it's a quadratic because the highest power is 2, so we should be able to recognize that. And so what we talked about is that we always want to start with our vertex. And so remember here that this negative is part of the formula. So when we have a negative number, it really translates to a positive h value. So this is a -4, but what we know is that the x-coordinate for that vertex is a +4. And the k value is just as it appears on the outside of those parentheses, so that would be a +1. So what we know is that the vertex will be 4, 1 right here. All right, just drop that dot. All right, now what we said is that the number in front here is our a value, and the pattern that we discovered this year is that we can use a, all right, and then 3a, which so 3 times 2 would be 6. And if we have enough room, we could do 5a, which is 5 times 2, which is 10. And we can use mainly a and 3a to generate the next couple of sets of our points. So if I use my a value, it is 2, so that means I'm going to go vertically up 2 to the right one, and up 2 and to the left one. And then I'm going to do 3a. So now from this point, I'm going to go up 1, 2, 3, 4, 5, 6 to the right one, and then up 6 and to the left one. Now the true challenge will be how well can I try to connect all these points. Oh, I missed. And it just kept going. Oh my goodness, that's just horrible. Horrible. Let's try again. All right, and so I'm sure you are there we go. All right, a little bit better. But you get the general idea. And the idea is that this should be hopefully a smooth curve down here, all right, because we know that the graph of a quadratic should look like a U. All right, so I'll do this one with you right here. All right, then I'll let you hop off and try a couple on your own. But once again, if we identify that vertex first, all right, we're going to look inside, find that value for h. Now notice this is a +6, all right? And the way we get this negative that is part of the formula to change to a positive means that we must have put a negative h value in. So that means our vertex is -6, all right, for the x-coordinate, and then our y value would be that +4 as we see it. So if I go to -6, 4, there it is. Now our a value, remember that if there's just a negative, all right, or if it looks like there's no number in front, it's either -1 or +1. So in this case, a is -1, 3a would be -3, and 5a would be -5. All right, so now -1. So down 1 to the right one, down 1 to the left one. Then we're going to do 3a, so down 3 to the right one, down 3 to the left one. And now since we have room, I'm just going to go ahead and do this. 1, 2, 3, 4, 5, and then right there. And if we mirror that point over here, we get that. And then let's see how well I can try to do this. Oh, So close to getting to that point over there, and then it just keeps going, continue on. But I think you guys get it, I hope, with my bad drawings that you're much better. All right, so here's what I'd like you to do is pause the video. All right, give it a go. Give me your maximum effort on these problems. What? Did I say maximum effort? Did you know there's a song, Maximum Effort by Nerd Out? Here, I'll give you a shot of it right here while you're doing these two problems. Deadpool? Oh, my favorite! Oh, sorry, I meant to stop it right after it said maximum effort. So, all right, hopefully you finished these two examples. So let's check and see how you did here. All right. So on our first, number 3 here, the first one you did by yourself, hopefully you have a vertex of -7 and -8. The a value is 3, and the next value would be 3a, which is 9, and then I don't think many times we're going to get to 5a in this case, with it being 15. So let's see, -7, -8 would be over here. All right, right there. And then up 1, 2, 3 to the right, up 3 to the left. And then we do have room to get to 9 here. So up 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right one here. Now I'll mirror that, put that point right here. All right, and then hopefully you guys have an easier time of drawing than I do. Oh, I think I actually got like most of them, and then it's going to keep doing whatever it wants to do. All right, let's move on to number 4 here. And let's see if you got the little challenge here on this one. And notice this one's a little challenging because we don't have the parentheses here. There is no h value. And if there's no h value, that means our vertex, all right, is going to start with our x value of 0. I guess that's a 0. All right, and then our k value would be 7, just like what we see outside like normal, like we did the first couple of problems. All right, so remember, no parentheses, all right, when we're in vertex form tells us, all right, that the x value would be 0. All right, so I don't know, it seems like that part is struggling. Yeah, let's get rid of that and delete that. And let's see if I can maybe get a 0 here for you guys. As I'm trying to get this 0 drawn, hopefully, all right, let's try that. There we go. All right, you got an a value of -2, and then your 3a would have been -6, and then possibly a -10. All right, so if I start at 0, 7, now remember that's a y-intercept, then down 2 to the right one, down 2 to the left one right there, and then down 1, 2, 3, 4, 5, 6 to the left one, and then down 6 to the right one. All right, and we've got a little bit of cleanup to do there. All right, but it looks like that would be, all right, our 5 points. And we really want minimum of 3, and as many times as you can get to 5, we want you to get to 5, all right, when you sketch your graph. All right, so let me try to draw this in here. You see that I'm getting a little bit of no, that's not going to work at all. All right, so let's try that again. All right, so maybe I'll start up here and try to get smarter. Maybe it'll be easier for me if I try to do it this way. Oh, I'm still not very good. All right, bummer. Okay, well, let's move on and add another little bit of information to this, okay? And so if we look at the next page of our notes, okay, when we talk about this, we know the vertex is the most important part of our quadratic. Now, what we know is that a quadratic is either going to open up, like we see here on the left, or open down, like we see here on the right. And then what that means is that our graph will either have a maximum value or a minimum value, depending on which way that graph opens. So now, when we look at the red graph here, it opens up. And so notice we can see that our vertex here, all right, is 3, -4. All right, we can see that point right there. So 3, all right, -4, all right, right there. So let me just And make sure that's open so you know it's a 4 there. All right. Now, if I look at my next graph, I can see that the vertex here is, all right, get rid of that maybe. All right, struggling with the writing today. All right, not really wanting to write cleanly. All right, so if I look at this one, we can see that the vertex is 2, comma, -3. All right, so now really the x-coordinate is telling us something about that vertex and the y-coordinate is telling us something about that vertex. Now, so the x-coordinate represents the where. Okay, so where is that maximum happening? Where is the minimum happening? The y-coordinate is telling us how much. So when I look at this, my vertex is 3, -4. So at x equals 3, what we see is that the quadratic has a minimum value of -4. And what that's telling me is that nowhere else on the graph will it go lower than -4. All right, and you can see that, right, here's -4 right over here, right? And our graph is never going to get below that value. Now, if I look at the purple graph over here, and we see, all right, my vertex is 2, so at x equals 2, this quadratic has a maximum value of -3. And so what that is telling me, all right, is that if I look at -3, there's nothing in this graph that'll be above that value. And you can see that that's true with the purple here. Now, that's going to help us down the road. This is kind of just using something that we already know and we're familiar with to kind of discuss another concept, but eventually we'll get to some application questions where knowing what the minimum and maximum value are and what they might represent in a problem will be very valuable to us. Now, the other part that we're going to just quickly discuss are what we call solutions or x-intercepts or roots. All right, and this is basically where our graph crosses our x-axis. All right, and so if you look at our red graph here, you can see that there are 2 solutions. It crosses the axis, all right, or touches the x-axis twice. When we look at the purple here, this is our x-axis up here now, all right, and you can see that it just barely touches. It touches in that one exact spot. So we have one solution here, and then no solutions. You can see that once again, here's our x-intercept up here, all right, and you can see that our purple graph does not intersect the x-axis. So what we should understand, and we've seen this from our solving, from all the algebra we've done this year, that we know that when we solve a quadratic equation, we get 2 solutions sometimes. We get one, and we definitely have seen problems where we have no solutions. So all we're going to do here for the last handful of problems, okay, is just graph it and then answer the questions here about how many solutions, what are they, and all right, about whether it has a max or min value. So what I'm going to do is just do the first one with you to make sure you kind of understand all the pieces, and then I'll let you finish the last 3 examples. So now when we look at this, once again, looking for our vertex, we have a -2 here, so that tells me that my x-coordinate for my vertex is a +2. And then there's nothing out here, which tells me that my y-coordinate for my vertex is a 0. So I'm starting at 2, 0, which is right here. Now, my a value is a 3, which is here. 3a would be 9. Now, this is one of those cases, all right, where once I graph my a value, so up 1, 2, 3 to the right 1, up 3 to the left 1, I'm really not going to have an opportunity to get to 9. I'm going to go off my graph. All right, and so that's why we say 3 to 5 points, because sometimes we can only get those first 3 because that next value is such a large jump we may not be able to fit it onto our graph. But let me go ahead and try to sketch this graph here. All right, so there's one half, and then if I turn and go up, there's our second half. All right, now when we think about x-intercepts, all right, we only have one solution. There's only one, and it is the vertex, which happens to be, all right, the x-intercept. And that's when we're going to have one solution, is when the vertex is the x-intercept. Now, our quadratic opens up. And because our quadratic opens up, this vertex gives us a minimum value. Now, where does it occur at? It occurs at x equals 2. And we have a minimum value of 0, which means nothing else, right? We're not going to hit any of the values down here, and you can see that graphically. All right, so 3 problems left. Shouldn't take you too long. Pause the video, give 6, 7, 8 a shot, graph it, answer all the questions about it, and if you want, you can listen to a little bit more maximum effort while you find those maximum and minimum values.
Minus all the ethics. Wolverine, please answer the phone when I'm calling you. We need you on the team. Maybe he'll respond to auto-tune. Can you come out of retirement? Everything you do is so inspiring. Remember when you killed that one guy in Japan?
All right, so hopefully you finished all that. You paused the video. I know, I'm sorry. Trying to do what I can to make it a little bit lighter for you. And hey, maximum effort, right? On my part, to be humorous, to make this a little less, I would not say boring, but maybe you find it boring. But anyhow, so let's take a look at this. So hopefully you saw that your vertex was -5, 3. All right, you have an a value of 1. 3a would be 3, and 5a would be, in fact, 5. So if I start at -5, 3, that would be right here. And then I have 1. Oh, I'm sorry, I'm going in the wrong way here. So let me get this guy out of the way here. Delete that, and let's start again. And so once again, pay attention to which way your graph opens, because it's really going to have an impact on your solution. So -5, 3 is right here. And then now my a value is up 1 to the right 1, up 1 to the left 1. And then I'm going to go up 3 to the right 1, up 3 to the left 1. And then now let's see if we can join all those up here. All right. Oh, my thickness. All right, so there we go. I'm not sure why this keeps changing on me. All right, you've heard that like 1,000 times, right? Now notice, how many solutions do we have? How many times does it cross the x-axis? 0 times. We have no solutions here, okay? So you can write 0, you can write none, all right, but it does not cross, all right, the x-axis. Now, it does still open up, just like this one opens up. So what we know is at our maximum, we're gonna have at our vertex, we're going to have a minimum value. So that occurs at -5. And we are going to have a minimum of 3. All right, and we know that nothing is going to be below that value. Okay, so now let's take a look at the last 2 problems here together. And then we'll be done for the day. All right, so looking at our next problem. All right, I'm just going to adjust this here. All right, so hopefully you have a vertex of 2, -8. All right, you have an a value of 4. 3a would be 12. And I'm not going to bother with 5a because I definitely don't think we're going to get that much. All right, so 2 -8 would be right here. All right, and I'm going to go up 1, 2, 3, 4 to the right 1. All right, to the left 1. Now, I do think we can get 12 in here, so I'm going to do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and to the right 1 right there. And then I'm going to have this guy right here. All right, and so going to be a very skinny graph here because it's increasing pretty fast. All right, and around it here. Oh my goodness. Oh my goodness. Oh, that's just really, really bad. Stop! Don't. Oh, I don't know why it wants to keep going. All right, so way up there. Now, oh. Not pretty at all. Not pretty at all. Now, sometimes this happens. We do have 2 solutions here, all right? And notice they're not exact. They don't always end up at an integer value like 4 or 3. And so sometimes you might just have to estimate a little bit. So that first one, let's say, is 3.50. All right, the one on the right. And then I'm going to estimate this one at like 0.50. And once again, we're going to talk about some other methods. All right, and this is one of the weaknesses of graphing, besides my inability to actually like draw a graph, is that we don't get exact solutions. We have to estimate a little bit. Now, we still can be exact with our vertex here. Once again, it opens up. All right, the vertex is at 2, and because it opens up, we know we're going to have a minimum value, and that minimum value this time is -8. All right. So let's finish up here with our last problem, all right, and see how we do. All right, so hopefully you have a vertex of -3 and 5. All right, you have an a value of -1, a 3a is -3, and then 5a would be -5. All right, now if I graph -3, -5, or excuse me, -3, 5, so -3 and then 5 would be here. And then I'm going to go to down 1 to the right 1 and left 1. I'm going to go down 3 to the left 1 to the right 1. And sometimes this is where we have to do 5a to try to give us a good fit here. 1, 2, 3, 4, 5, just to help us with those x-intercepts, right? So if I try my best here, all right, and then come back here and there we go, missed that one, stop. All right, and then once again, you can see that we have two solutions, right? And once again, they're not necessarily integer answers, so we just want to approximate this. So this is like maybe -5.2, -5 point something. And we really just want you to estimate that. As long as you're somewhere between -5 and -6, all right, that's really what we want, all right? So if you write -5.3 and the answer key says -5.4 or something like that, no big deal. All right, and then the other one looks like it's probably like -1.2 or something. All right, so just a little bit there, all right, based on my graph. And so you can see that that's a little bit hard to tell, so just approximate. All right, now we do have a maximum here because our graph opens down this time. So at x equals -3, we have a maximum value of 5. All right, and that is it, my friends. Great work today. Glad you gave a maximum effort today. Hope you are doing well. Take care of yourselves. All right, let us know if you have questions. All right, email us. All right, sit in on our Google Hangout or Zoom sessions, whichever one we're doing. All right, look forward to helping you if you need it. Otherwise, I will catch you next time, my friends. All right, later. Woo!